Controlling a Traxxas Teton with the PlayStation 2 controller and the Arduino Uno. Now I have data pins. The data pin right here is the first one connected to pin 13. The command pin I have to pin 12. You skip this third pin, then you have ground and 3 to 5 volts. And then I have the attention select pin going here to pin 11. I have the clock pin going here to pin 10. So in order, 13, 12, 11, 10. And then the middle two again are ground and power. Skip the third, do not use the last two. So I have the 5 volt and ground going to the breadboard. And then pin 9 is sending the signals to the ESC here. Let's see right there. And the ESC is grounded at the Arduino. You do not use the center power 5 volts here. Do not use it because we are powering it with a separate battery here. I'm using a nickel metal hydride battery. I've got the servo connected here. We use ground and power that I've got going to the breadboard. And I've got signal going to pin 3 in the Arduino. And here I've mapped the right stick to steer like I would in a video game. And the left stick, slowly increase. Whoop, that was a little fast. See if I can get a little slower this time. Use my left hand. That's what I would normally drive with. Oh yeah, there we go. And then down. Down's a little, yeah, that one's pretty sensitive. And that's the thing with using PlayStation controllers. The analog sticks are pretty sensitive. But it does arm itself when I hook it up, which I'm going to show you the code in just a moment. That red light lets me know that it's been initialized. And I sent a 1500 microsecond pulse to it. Here I've included 3 libraries: the servo library, the wire library, and the PS2X library. I've defined the pins for the PlayStation controller: the data, the command, the select, or also known as attention, and the clock. And these are the Arduino pins they're attached to: 13, 12, 11, and 10. Then I created the PlayStation 2 controller object here. Now I need several variables to read in from the analog stick. The LX is the left x-axis, left stick x-axis. This is the left stick y-axis, and then also right stick x-axis, right stick y-axis. For the PlayStation controller, we're going to need to check the message received from the gamepad. We've got to set up our ESC and our servo, create those objects, and we're going to use these 2 variables to map the analog values with the microsecond value that we need to send to the servo and the ESC. And then we attach the 2, the ESC and the servo. The 57,600 bits, we need this much for the PlayStation controller. Let's see here. Just copy and paste all this. This is just checking that code that's coming back to us. And then in our loop, here's where we initialize the ESC with that 1500. All right. And then we also set the servo at a neutral position of 90. And then we have the PlayStation 2 controller reading the gamepad, set false or 0, or you can just delete both of those, it doesn't matter. Here we're reading the values, we're calling the analog function and sending in the name of the stick. And this comes with the library. So there's a keyword file with the library that you'll need to read, and you'll know the names of each button that comes with the library. So you'll know what to pass, what you're looking for. When I ran my tests, the serial monitor here, right, that's way over there, isn't it? Right here. All right, this serial monitor, it was constantly showing me 127 and, and also 128. So I set my values according to what it was reading. And for it to stop just blasting down the serial monitor, I put, if it is less than 127, then here we're going to speed up. We're going to use the left y-axis and map that value right here. That's the variable. And then this is what it should be, 126 to 0, because the PlayStation 2 controller is reading 0 to 255, but I want it to stay between 127 and 0. And then the minimum and maximum pulse width. So 1500 to 1000. And then we write that in microseconds. The ESC right here, that's what we're taking in. So that's speeding up, and then here's the speeding down. All right, we've got turning left, and the values here, 135. I don't want it to go all the way to 180 when I take a left. So I took off about 45 degrees, and I did this on both sides. Instead of going down to 0, when I take a right, I go down to 45 degrees. That's because when you look here where the servo is, we don't want this thing, you know, just constantly hitting this and those motors inside grinding. So I put a limit on it for how far I can turn. And my controller turned off. So just gotta press start here. There we go. And then the rest of the code is, you know, it's just sitting there. I don't have any of the buttons attached to anything, but you're free to, you know, set it up how you please. I used, again, the PS2X library. I can't think of the guy's name. It's on GitHub, but I will pull it up right here. PS2X library. Yeah, this guy. He gives us some great example stuff. Here's the keywords I was mentioning. Examples, PS2X example. And here, I just looked at his code and used what he had. And added the servo. So there you go, guys. A Traxxas Teton with an Arduino Uno and a PlayStation 2 controller.